we discuss today's topic is automotive cybersecurity, like overview, perspective, and challenges. So here, what is the automotive technology? As we know that automotive technologies is all connected with the like vehicles, all vehicles. These are the automotive technologies things plus IT. Nowadays, we know that as much as our vehicles have advanced, they are more integrated with the IT or the information technologies like IT industry. So for the automotive industry, we need the safety culture. We need to think about the safety point of view, and IT, we need to security. What does this mean? Security culture, like we have connected with the Wi-Fi communications, we have data storage, our vehicle locations, navigation. We are using so much IT things in our vehicles, so we must to secure about from the cyber attacks. So as we know that modern cars are run by 10 of ECUs comprising millions of line of codes. ECUs are well connected over internal buses, mainly CAN buses, whereas ECU is the electronic control units and the CAN is the control area network. Yes, similar if we connect with our networking point of view, there is a WAN and LAN and WAN, those type of things in the automotive technologies. So ECUs are well connected over internal buses, mainly CAN buses, to enable both critical safety and convenience features. For example, engine control, brakes, steering, phone connectivity, Bluetooth, cellular functionalities. Those of the functions, advanced functions are enabled in our vehicles nowadays. And then we need to connectivity for the alerting, by alerting the drivers. For driver, we need to alert the when is oil is less, when is the way our communication is going wrong, and all those things. Warning, oil pressure warning, engine efficiency information, and voice control of the car. This type of some examples. So now we can see how automotive is growth, automotive technologies development is going on. So as we know that application of knowledge about the self-propelled vehicles or machines, the autonomous vehicle is learning about engine construction, fuel ignition systems, powertrains, brake, transmission, electronic and diagnostic equipment, and more. So many things. So there is SAE, Society of Automotive Engineering, the standard they define some level of the driving automations in the our vehicles. So like till 2030, we believe that automotive technology will be the fully autonomous. Approximately 20% vehicles will be the autonomous vehicle. So here is we can see that levels of self-driving car, our automations, driving automations, like passenger services. Previously we see in our old age there is an open connected platform, there is a new or legacy cars are available there. Then we when we do the mass differentiations and in car services, then we using the sensors inbuilt our vehicles, the trying. Then we are nowadays, as we know that electrical vehicles too much demand. So when vehicle interaction, during this vehicle interaction level, vehicle can be connect with the vehicles and also connect with the infrastructures like ITS system, intelligent transportation system, those type of things. So they offer market innovation and living service ecosystems. Then now is coming to more think about the environment, traffic and mobility. Mobility, like when we are moving sometime, then we get the information, we get the details, data from our locations where we are going and how to like GPS and those type of navigation systems will be start the environment and traffic and mobility during this level. So in the traffic as an ecosystem, energy, environment and mobile technologies they are using in the vehicles. And the fully automated level 5 is fully automated and connected. There is a safety and security, cost and ownership, convenient services. Like we know about the some services, where is a petrol pump, where is the some restaurant, where we are going on the highway. So how can we get those informations? So that is will comes in the fully automated, and in fully automated connected vehicles they will be, we can call the self-driving vehicles, self-driving car. So we give the more detail. We go for the more details about the level of vehicles automation. Here in level 0, there is a vehicle driver only. Based on the vehicle be connected, communicated or handled by only the driver. They cannot connect with the out of the vehicle, out of the environment, out of the vehicles. So they conventional vehicles driver manage all aspect of the speed, direction and location. Those all things is based on human driver, based on drivers. Second one is level 2. So this type of vehicles will be the example of the level 0. Level 2, there is the assisted by the some technologies like driver receives support from a specialized task. For example, parking and indicators, backlight, those type of some examples is added in the more features in the vehicles level 2. These are some examples. We can also say that some sensors is also included. And level 2, these are the partial automation. Driver receives support of coping with the predefined scenarios like services, inflict, finding the location, navigation, GPS, and also get the traffic jam warning and avoidance etc. This type of some information is getting, we can getting the level 2 type of vehicles. Then level 3, they have a conditional automation. That means the driver can relate control to automated system. That means driver can be self-drive also, semi-automation, like vehicle controlled by the driver with the self-driving automation things. For example, autopilot, motorway, these are some examples. So there is a driver can be relinks control to automated system, but must be ready to take back the control. So like motorway, autopilot, these type of examples. Level 4, they have a significant automation. Now, significant automation means the majority of journey may be automated by the some driver. Interventions may be required. For example, urban motoring. Then during the urban side, urban traffic, when we get it that there is a lot of traffic jams and so many things. So vehicles will be self-drive, and this also controlled by the human. Last one is level 5. There is a complete automation, the complete end-to-end journey without the driver intervention. This is we are waiting for this type of vehicles like Tesla and Google. They are working on this type of vehicles. So when this type of vehicles come, then it looks our advanced technologies, advanced automations, vehicles automation. So they will be connected with the everywhere. You can see in this diagram, it's connected with the get the messaging, get the navigation, connected with the home also, connected with the office also. So this type of vehicles will become in when this level 5 is completed. So now today's automotive technologies has this type of features like powertrain, body convenience, safety, infotainment. Like powertrain, it has the engine control, transmission control, starter and alternator, body and convenience, that light control, that will be vehicle buses, connected with the vehicle buses, the sensors, heating, ventilation, air condition, power operated system, seat and door, and this remote keyless entry of the vehicles, alarm. If someone is try to access our vehicles, then it bring that alarm, keyless alarm, those things. And for the safety purpose, they are using the ABS braking, power steering. The steering has so many things: steering, suspension, TPMS, the tire pressure management system, TPMS, and airbag is a passive restraint driver assistance system. So these are some features for the safety purpose they are using, but it is using by the organizational, the automated vehicles developer companies, industries. So they are using the safety purpose, but for the security purpose, still they have lake up to getting the knowledge about those things. So in the infotainment, we have the navigation, car radio, car audio, telemarketing, dashboard, in-car multimedia. This type of all today's vehicle we can get this all features in there. So in automotive technologies, the advanced features has this providing the connected added value features in order to the enhance car users experience or improve the car safety. Use cases such as telematic, connected infotainment or intra-vehicular communications. As we discussed about the vehicle to vehicle is communicating, vehicle to infrastructure communication, vehicle to person communication through the mobile phones. Those type of communication is going on in this current situation, current scenario, upcoming scenario, like high level architecture for the connected vehicles. We need like this powertrain control area network, that is a CAN, multimedia network, vehicle control networks. So powertrain, they will using the transmission control, engine system, and they connect with the sensors. How do they connect the sensors? And then control area network, they have also provide the connectivity with the steering or safety brake. This type of control area network will be accessing the information from the sensors and this providing this type of features. Then it is using it called the ECU, electronic control unit, that enable with the telematic communication. As we know that telematic communication means that connected with the mobile phone, connected with the cellular phone, or connected with the wireless Wi-Fi connectivity, those things. And then third one is the multimedia network, that have we already enjoying this type of radio, audio, video, those type of features in our vehicles, locations and devices. So many devices can be connect. We can connect to our vehicles nowadays. And then vehicle control network. They have the speedometer, temperature, door control that we are already using, and it will be all connected with the onboard diagnostics. That is called the OBD tool. So other way, on the way, automotive technologies. These are the on the way. We are going to. We cannot say that these are the developed, or we cannot say that is not developed. They are on the way means they are in developing time, developing mode. So many, like we already heard about the Tesla has doing so many testing, self-driving car, and they have some issues, some accident has happened with the Tesla like that things. So there is on the way that automotive technology feature we have the connected car that connected with the smartphone operating system, telecommunication network operating systems, the standards. So we need to require this type of specific skills for the each developing of the system, developing our advanced vehicles. So second one, driver information system, including the ADAS, warnings, driver assistant. They need the wireless connectivity, understanding of relevant and connected the HD display or sensing. We can see that display movies and those type of things, videos. We can using the camera. We can see the backside and parking things. Those type of connected SD high quality display. So we need to protocol stack, Ethernet, and security image analysis and graphic processing. Like we need to most machine learning and those type of technologies. We need to add those things. Then predictive HMI, human motion interaction, that is display and touch technologies is needed. Then seamless CE devices, that CE devices integration they have using the human machine interface and graphics design. They can be provide that connectivity environment. CE is connected environment, seamless connected environment, those things. And then we also working on the vehicle and driver contextual and situation awareness, that we have some issues, some traffic jam, some accident has happened on the road. So driver and system can be get the message from the location environment and location contextual information and situational information. For this we need the skill for the optics and image projection technologies, multiband receptions, software and defined radio, smart antenna technologies. Then we have also cloud services. That cloud services need a complex electronic system, architect engineer. We need to connect Linux, HTML, JavaScript, this type of some languages. We need to skillful developers need that thing. So cloud services, they provide that information about the vehicles information from there. So what type of services, any vehicles want to some services, so he can get the access that information from the cloud. So then automotive technologies feature, these are the similar as the features, what type of features we needed in the futuristic vehicles. We need to high mobility, high relative speed, and high dynamic prediction mobility, that can be get the random mobility, fast channel changes, the frequent network channel changes, high communication overhead for exchanging new topologies information, navigation, use a global positioning system to identify their location with the high accuracy, abundant network nodes, very large network due to high density of the vehicles, to delay constraint, that is the safety messages we get the should be given a high priority and must be the delivered on the time. Restrictions, the governed by the restricted rules, the traffic flow theory rules, no power constraints, need the power supply for all communication and computational tasks. So as we see that these are the features, these are the basic requirements for the advanced vehicles. So in this all features we can find that this all need to the IT, we need to the cyber world. As much as the cyber world is working, that is the security issue is always be there. So that till here we have discussed about the automotive vehicles environment. What type of vehicles gonna be developed in the futuristic vehicles. In here we discuss about the vehicles communication, how they will connected with the vehicle to vehicle, like that things. So for this, for vehicle, share the data with any communication enabled device and infrastructure such as V2V, vehicle to vehicle communication. There is a smart vehicle, we have connected the sensors, can be provided information about their locations and all things. Then vehicle to everything, V2X, there is providing infrastructure, connected with the infrastructure, roadside units, electronic devices, and in vehicle inside a vehicle they are connected like CAN, ECU sensors, they are connected to and exchange their data, their informations to within our vehicles. As we see in this environment, vehicle connected with the vehicular clouds, we can call that this is a V2 RSU, that roadside unit, connected with the Wi-Fi, connected with V2I, that is vehicle to infrastructure, vehicle to cloud, vehicle to vehicle communications. They are connected with each others and they will providing or changing the informations within their respective environment. So for this vehicle communication, we need to find the this is the standard channel. They are using the method for the communicating vehicles to vehicle to environment. These are called the dedicated shorted range communication, DSRC, that algorithm. So that's developed based on the Wi-Fi standard. It's to provide the secure and reliable communication links among the vehicles and between vehicles on infrastructures. So short time response, less than 50 milliseconds. It given the response within just 50 milliseconds. And then operates with the 5.9 gigahertz channel. So these are some channels like require extensive and expensive build out. So here is the channels. What channel is the providing by the standardized for the vehicle communications, where we can see this channel is work within a 5.850 to 5.9250, but it will works more effectively in the 5.9 gigahertz, like in this gigahertz. So DSRC is providing that type of method, that type of channel that can be where vehicles gonna be communicating each other. Then vehicle has another algorithms, another method they're using for the communication that calls the wave. That is the wireless access vehicular environment. How can we access the wirelessly for the vehicle informations to some locations point of view? They are using the wave method. So WAVE is to provide the wireless access in vehicular environment. WAVE architecture is developed by the IEEE 802.11p and IEEE P1609 is the standard of the wave communication, the vehicular communication environment channel. They're providing that things. So the IEEE 1609 is provide the higher level protocol, and it will be and IEEE 802.11p is provide the physical and media access control. So in here we can see they are also including the security 1609.1 is for the resource management, then 1609.2 that is the using for the security, and 0.3 it will using for the networking, and 2.4 will be using for the physical multi-channel and operations for physical and MAC address. So the wireless access vehicular communication has this data, this size of information. So in here we are most concentrate about the security. We not discuss about the resource management and networking and multi-channel based on the topic. So this is the vehicle communication where we need the security. That is the in vehicular communication. That is the first cooperative collision warning. If there is a two vehicle gonna be collapse, gonna be collide with each other, they must get that share their information each others. Then lane change. If some vehicle is changing their lane, so it must be informed, must be get the secure information to another vehicles, and then another vehicle must be the believe on that this message comes from the trusted vehicles. Intersection collision. In the intersection, during the intersection, it needs the information that we are coming on this intersection. So please, each vehicles must be securely connected to each other. Approaching emergency vehicles, roller warning, work zone warning, coupling, decoupling, inter-vehicle communications, and electronic toll collection. So these are the informations, these are the communication way where we need the securities for the vehicles. So cyber security in vehicle environment, where we get in this information, where we need to security. We need to security in the cloud connected, when vehicle connected with the clouds. We need the security is where is the policy enforcement and based management. We need the security for the communication services providing the fog and energy service providers. We need the securities in there connected with the mobile Wi-Fi, offload and hotspots. We need to connect security for the DSRC roadside infrastructure communication. We need the security for the consumer network. We also need the security for the electric charging network, charging stations and other services of the IEEE 802.11p. So we can see in this environment, that is a whole vehicles communication environment. So we need to security for each and single level of the security. So we must be think about we need the security in the vehicle also. There is a mobile that can be require the secure communications, those things. So automotive cyber security perspectives, we can see that cyber security is critical to the connected vehicles. For the connected vehicles and analysis in the three domains: IT security, V2X communication security, and in-vehicle security. So in this diagram, we can find that there is a V2X security where is communicating with the environment, where it is connected with the anything, with the persons, with the infrastructures. So that must be the need the security. We need to security inside of vehicle, because there is a node is we know that our vehicle has a lot of sensors, so nobody cannot be modified the sensors informations. So we need to security in the inside of vehicles, and all vehicles is connected with the IT. So we need the IT security is the most important for this whole vehicle environment, whole automotive technology. So we can see that IT security is the standard, and V2X is providing the 802.11p in vehicles. They have the provide the security for the each type of some sensors, area networks. So automotive secure development life cycle. As we see that automotive development life cycle is connected for starting from the design. We cannot implement the security in the just after the vehicles comes on the road. We need to think about the security from the designing phase of the developing of the vehicles, developing of the any autonomous vehicles or any type of vehicle. So it will be start from the system design, then asset the protection definition, where we need to think about the develop the all threat models. What type of threats gonna be happen and gonna be affect our vehicles. Those type of things we need to think about those, making those that threat models also. We need to define the countermeasure. If some threat is happen, then how can we countermeasure the vehicles? We don't need to do like, we need to countermeasure immediately. Like something happened, some brake has jammed, or some sensor is coming the wrong data, and we getting some wrong information for the traffic related information. So we must to think that message is the correct or not. We need to respond immediately. We need to countermeasure that immediately. That is the verifying those informations. So we need to define the countermeasures. How can we make the countermeasure of the any type of threats? We need to think about the best practice. How can we provide that security with the best practice of this? We need to do the testing our security issues in the vehicles. Then we need to provide the security assessment. How do we access the vehicles security? And then incident response plan. Incident response plans means some incidents happen, then how can we respond to vehicle during the vehicles in advanced vehicle time. If some vehicle is in automation mode, vehicle is running himself, and some object comes suddenly in front of vehicles, then how can he respond? He's gonna be brake and he's gonna be control the speed. How can we gonna respond? We need to find out this immediately. We need to pre-plan. We need to teach our vehicles in the coming down the road. So that is all the automated secure development life cycle. So how can it works that development life cycle? System design, we need to advise efficient use of security technologies and management of the associated risk. Asset protection defined, we need to provide the anti-theft that nowadays is providing the alarm if someone is legally using that vehicle, touching their vehicles. And revenue streams, such protection of software enable the functionality. Threat model is provide the spoofing guarantee, tampering data, repudiation, information disclosure, and denial of services. This type of action has happened, then how can we? These are some threat model that can be affect our the vehicles. Then define the countermeasure, restrict to reach of the features, bind only appropriate network interfaces. Best practice is the security awareness training. The technologies are service selection, security and privacy advice. Security assessment, that is penetration and attack testing, runtime analysis of fudge testing, static source code analysis. These are some basic security assessment we need to provide that our vehicles. Then incident response plan, that's publicly released details of security flaws. What type of flaws has happened in publicly, must to be disclosed of the publicly those things. Then malware created by the hackers are released in the wild. Hacker has managed to install the custom firmware and those type of things. We need to find out this, or how can we have our vehicle will be response and during this type of attacks. So these are the features of the basic automated secure development life cycle. Now, why we need the automated cyber security needs? That cyber security needs to connect the vehicle's environment, trust that the other entity is really who it claims to be. We must be the authenticate and authorized. These are the legal entity we gonna be use or access our vehicle. Trust the process and mechanism by which they are exchange the information. For this, we need the encryption method. Trust the actual information exchange. We need to data integrity that can nobody gonna be modified if once a message is coming in the network. So no one gonna be change that message. For this we are using our data integrity methods. Then trust the negotiation process and final contract. For this we need the digital signature. Trust the negotiations. Like if we are negotiating in the something on the traffic signals, someone has some emergency and he wanna be go fast, he messages to broadcast in their neighbor's vehicle, they must be verify that, they must be believe on those vehicles, these are the connected, these are the trustable. For this they are using the digital signature method. Then trust trust that the other party will complete its contract and not defect. So for this we are using the non-repudiation mechanism. So these are some features where we're gonna be use this type of mechanism. We need to what type of security we need to implement in the each and some particular function, particular issues. So for example, that is automotive cybersecurity is some architecture where vehicle is connected with the vehicle to vehicle, vehicle to environment. So it will be the vehicle has a sensor, ECU, LDM. LDM is the data management, local data management, CC control units, and routing tables. Routing table is where is the vehicle gonna be parked, message which route is gonna be passed, message to the network, those things. And it will be infrastructure. They have onboard diagnostics connected with the Wi-Fi, connected has this router, and it has PKI, traffic parties, traffic management, and roadside unit management, where PKI is the private key infrastructures things. So these are the we need to this type of secure structure for our automotive communications vehicle. So here we can find out each step. During the designing step, we need to design software and hardware for automotive cybersecurity, to create trusted platform, to ensure interoperability, to confirm standard to automotive cybersecurity. These all things designing is need inside of the vehicle security. These are the inside of vehicle security. Then we to build the secure communication environment, to develop dynamic environment, it needs the V2X security. When vehicle is connected with the any things, everything. Then we need to build this type of security is developed during the building of the vehicles. Then services to ensure secure architecture for connected vehicles, to control vulnerability, pre and post threat, to allow users to use the services at the low risk. This type of security is needed when vehicle is connected with the IT system, V2I, V2 infrastructure system. Then we need this type of security. Our target is providing this type of each level security. Is the main target is provide the securing, content, authorization, authentication, message integrity, protect privacy and data security of vehicles and users of vehicles. So till here we had just discussed about that security issues, what type of security needed and what type of security is gonna be happen for the designing and developing our vehicles. This type of we discussed till here. Now we discuss about what type of threat and what type of security issues gonna be happen in journal is going on in our automotive security is happening once in our environment, in our current location type. So threat of data communication is according to ITU TX 8800, they are providing the threat data communication. They are defining these are the ITU is the European IT units. They are defining those things. These threats, they have provided destruction of information and or resources, corruption and modification of information, theft, removal or loss information and other resources, disclosure of information and interruption of the services. These are the main 5 type of threats gonna be happen during the automotive field, in automotive technology. So how can we prevent? It just define that, provide that to prevent this type of issues, integrate freshness, non-repetition, anonymity, availability, and confidentiality. Data, we need to use this type of method to protect our vehicles. It's defined by the ITU, that is European Union. So threat to infrastructures, it used the cyber attacks in the infrastructures, could cause, there is a traffic gridlock, economic losses, accident and lost life, massive insurance claims, political repercussions. These type of effect has gonna be affect the our environment once we are in automotive cybersecurity. We are not considered the automotive cybersecurity as a major things in our life. So these are things. So we need to think to broad terms like private vehicles, taxis, buses, drones, light rail, trains and light rails, pedestrians and cyclists, emergency services. So we need to think all of security is gonna be happen, all gonna be affect this all things in the during the infrastructure. So automotive cybersecurity risk. There is a risk. There is a first unauthorized access to vehicles. There is keyless door entry system. Use mobile app or electronic key. Theft of personal information, owner details, GPS log, credit card information. Hijacking of the individual vehicles. Feasibility demonstrated by the Jeep hack in 2015 is happened. This and creation of mobile bots, the vehicle software compromised by hackers and used to launch cyber attacks, installation of ransomware, victims must pay money to regain their information and regain their control of the vehicle. So this type of risk has possible to happen. So here we can again explain more. Automatic attacks vector, we have seen in this diagram has a lot of sensors. So it gonna be happen in this sensor. So what type of attacks possible? There is a man in middle, side channel attack, software modification, denial of services, compromised privacy, that can be happened. Automatic attack goal, there is gaining access to safety, critical functions, vehicle and theft, personal information of the driver, things, and automotive vulnerable systems. We have seen these are the some diagram. These are the some part is that can be vulnerable for the any vehicles. They have a driving strategy, vehicle control, braking, acceleration, active and passive safety, connected vehicles, automotive immediate risk, that is the compromised vehicles, safety functions, random vehicles misbehavior in critical situations, worldwide scalability of attack vectors. This type of some immediate risk can be happened in the vehicles by the vehicles. Then long-term automotive risk, that is a dramatic loss, consumer trust in for the vehicles, new vehicle features, decline attractiveness and trust by the consumer into the vehicles brand without clear cybersecurity strategy. So this type of risk, this type of basic examples that can be happened to with the risk of the autonomous vehicle cybersecurity, if we are not focused on this cybersecurity skill. So now we discuss what type of attacks gonna be happen. First, for example, just these are not the fixed attack that gonna be happen more type of attacks, but I'm just focusing some point of view, some examples. So first one is the bogus information attacks. They can be used adversary send bogus information in the whole communication network to influence the decision of other drivers, greedy drivers. For example, like this, they just make that some example that this vehicle is coming and he just broadcast the message, okay, I am hurry, and he's not thinking about the other vehicles. He just these are the attacker. He just informed all messages, he just modified interrupt the messages that these vehicles have no vehicles coming in there anyway. So this vehicle has gonna be accident, gonna be in this intersection. So it will be advisory send the bogus information in the VANET. So it will be, this hacker can be influence the message through the bogus message with the all drivers of this vehicle or on the vehicles. Then we have disrupt the VANET denial of services. This example, like attackers send too many messages and jam the wireless channel. So no vehicles can be get the any information, any messages for the what type of traffic information. So it can be vulnerable, is gonna be disrupt the whole vehicular network. Then vehicle tracking data integrity. For this, they are just like attackers send that, okay, these informations, the next vehicle informations to the broadcast. He just copying their informations and send modified the what one vehicle is sending their message, is changing their whole messages in the network. Then masquerading attack. Active attack is attempt pretend to be another driver by using the fake identities, can be provoked by the malicious objective. These are another examples of this information. So in a roadside unit, the car C is sending some fake message in the network and changing their identities with the attacking mode. So this type of threats, this type of attacks can be destroy the whole networks, destroy our vehicles, destroy the complete informations and modify those things. So how can we protect those type of things? How can we make it that things to make more secure? We need to use the automotive network cybersecurity. For this, first we need to use identity authentication. That is the PKI infrastructure that can be used. The vehicle can be registered their private key informations to share with the other vehicles, and they communicating with with the help of PKI, their private and public key methods. Then false information, how can we protect that? We need to data correlation. Data must be correlation, like randomly some vehicle is sending some information and receiver receive the informations continuously that is not correlated with the previous information. Then we find that okay, this is coming from some wrong site information. Then DOS attacks, denial of services attack, it can be possible to protect with the help of switching the channel, switching the communication channel. And then privacy is using changing the pseudonyms. So it can be used with the help of mobile connectivity and all things to provide that type of secure our automotive attacks. So automotive cybersecurity challenges and possible solution has another issues like challenges is the protection against technical failures. For this, we need to ensure that security and safety aspect in the context of vehicular communication environment. Protection against the malicious and manipulation of intrusions. It can be happen with the technical IT securities information. We need to manage safety and security during the software development upgradation. Quality attributes is need the end user trust on application and interconnected computing platforms, and security relevant organizational policies and the process. For this, we can protect with the help of providing the trustworthy open automotive ecosystem and application store from end users centric perspectives. So these are some common basics attacks challenges. How can we protect our vehicles? And these are some basic solutions. How can we provide those solutions? With the help of those solutions, we can protect make our vehicles security, cyber security more stronger. These are the just overview structure of the automotive cyber security, where it's gonna be we need to end-to-end security. End-to-end security means when from the cloud, from the data analytics, from the data storage to vehicle to vehicle, vehicle to infrastructure, vehicles to person, in vehicle and another vehicle communications sections, and we also need to sensors, protections, to phone to car, and it's gonna be connect with the back office, billing, provision, operations, and other things. So if some vehicle automatic cybersecurity is needed to end-to-end information. So when that back office is just given example is coming from there, and it will be protect our whole automotive securities with the these sections to upside end-to-end security we needed. For example, that is the end-to-end security assisted by the trusted provider. Nowadays we are using the ITS system, that intelligent transportation system, and government has this type of some communication network, cellular network. They can be provide those type of security, end-to-end security. From here you can see this is the vehicle, it's connected with the one home, and the service provider provide the connectivity, and then there is a communication network. It's coming from the this secure locations, and there is another vehicle, that is the source where it's going from, coming from to this destination. The whole communication network is the make the secure by the trusted provider. That is the government nowadays is ITS system who's controlling those type of communications. This one is the hope to hope security. We need to provide that security in hope to hope. This vehicle to wireless communication between them, they have a security we need to secure. Then we need to secure between the wireless communication service provider to another hope, that is a cloud where is the data is stored, and then another is connected with the second service provider. We must to provide the secure information. We need to use the encryption methods during the communication. So these are the hope to hope security, and these are the some framework for the automatic cyber security where we using the software and services. So there we are providing the anti-malware and cryptographic services. They can be provide to connect with the network reinforcement, anomaly detection, and we can use the biometric methods, and we take the software updation in the over the air. So these are the how can we provide the protect the our software and their services. And for the hardware security building, we need to the blocks, the platform boot integrity and chain of the trust. We need to use the secure debug. They can be secure the deep storage with the keys and data. They secure the communication with the help of tamper detection and protection from the side channel attacks. So hardware security services that can be used by the applications using first device identification, isolated executions, messages authentications, and they will need the fast cryptographic performance. We cannot wait for the long time. We need lightweight cryptographic algorithms to provide this type of hardware protection things. So this is the complete automotive cybersecurity framework for the software and hardware. There's a hardware means in the inside of vehicles there we are using the sensors and those type of connecting devices. So the another framework for complete functionalities based on our network layers. So there is a functions, execution of application boot, key, automatic messaging. We need to use the application layer. In the application layer, we need the road safety, traffic information, other applications. And then we need presentation and session layer. We need to support application support, information support, and communication support. Then transport and network layer. We use that V2V, V2I, where is the communicating or where is connected vehicle to vehicle and communication is happening. We need to secure those layers. So V2V, V2I transport layers, V2 VANET network, TCP/IP, geo routing, and other protocols. We are using those places. And access technologies, we use the WiMAX, GPS, UMTS, connectivity between the vehicles. So for this hardware security, we need the secure middleware layer services and APIs. APIs has a secure key distribution, secure messaging, secure registry, provisioning, trusted time, software authentication, and cryptographic services. And then we have to, these all things happen between the hardware and software security. So these things happen in vehicle secure communication, software image process protection, multi-scheme DRM, ECUs authentication, secure V2X and V2V communication, mobile TV radio security, and secure the logging on. So these vehicles, these are the functions discussed about the whole vehicle framework inside of the connected with the hardware and connected with the software. This between that network layer, when vehicle is gonna be communicate, there's gonna be what network layer is gonna be, how to protect the to which methods. So these are the protection complete automotive cybersecurity network layers. So 3 layers for the securing in our vehicles we used to make secure in telematics, that application based telematic security, V2X security, and in vehicle security. So for example, this is the IT security model. There is automotive is coming, it's connected with the wireless networks, but there is must be their communication is happened with the based on the some private key, some cryptographic mechanism, the security. Then those data is stored in the data normalizations and event analysis. That must be also provide some secure information, some encrypted data, and then data can be connected with the systems from the data storage or analytics. These all process gonna be must be secure in each level. So here safety information, we need to accident prevention, emergency support, accident prevention. Traffic information is provide the ambulance notify, offering traffic information, search and guide route. Convenience service, we need to automatic tolling, weather forecasting, location information. So these are the which level has what type of support is needed. So explaining this here. So there is a basic 3 layers there, telematic and VDX and in vehicle security. So this securing 3 layers to vehicle, where communicating the vehicle communication to vehicle communications, where is the problems and what is the solution. So when connected with the vehicle communication, what type of issues gonna be happen. So that issue is first ID steal. They can be copy your some personal information, your registration informations from the vehicles. For this we need to use the liability identification to protect for the protection. We need to wrong message spread. Someone is sending the broadcasting the bogus message information. This last slide we discussed. We need to use the message authentication. What message is coming? It's coming from some authenticated persons or authenticated vehicles. The message tempered. We need to message integrity. That is the data integrity things. What messages we are receiving, we must to believe, we must to find out that this message is not modified. This message is the original messages coming to us, not tempered. Deny the message spread. Deny the message spread. Deny the message spread means that one vehicle is just sending so many messages, bogus messages or legal messages. So it can be denied. It can be provided protect that okay, some messages are not relevant with us, not is coming from the some attackers, someone not legal persons, legal vehicles. We can use the non-repudiation method for this, and then tempered vehicle personal, we use message confidentiality methods to secure this information. So here there is some standard of vehicle automotive cybersecurity. The vehicle, some organizations they are already working on those fields for the vehicles cybersecurity. So first, like Auto Alliance, there is consumer privacy protection principles and privacy focus. These are provide the asset protection. Then ISO 26262, these are providing the functional security focus with the system design and best practice and security assessment. Then certified C, they are security focused with the best practice guidelines and security assessment. SAE, Society of Automotive Engineering, that is the J3061, they are providing the cyber physical focus security, cyber physical securities. So it will be define the countermeasure, how can we protect those attacks with the threats of the vehicle. Then ISO 12207, It's provide a system and software engineering protection, security protection. They will give the best practice guidelines. Mishra C, they are providing the safety protection focus. They will focus on the best practice and security assessment. Then ISO 27001 is providing the information security management things. They are providing the response, security assessment and incident plan. These are the some another projects is going on like NISTA, National Institute of Science and Technologies. FIPS, they are providing the software architecture, design threads with the best practice guideline and system design architecture. The EVITA is protect the threat model, risk assessment aligned with the ISO 26262. EBRA, they are providing risk assessment telecommunication network focus with the threat model. And NIST FIS 1402, they are providing a security requirement for the cryptographic model. What type of security requirement is needed during the using the cryptographic models. Then STRIDE, it discuss about the threat model. Heavens and Octave both are providing this the threat model. What type of, so here we can find out that lot of projects is working on the threat models and their threat models and best practice and security assessment. So these are the internationally working some good projects by government projects is working on those automotive cyber security. Here another project, some we discuss about that in details. What are some standard project who's already developed or under development. So vehicular network cyber physical projects NHTSA.HS812333. They using the cyber security best practice for the modern vehicles. There is a national highway transportation system of the USA. PRESERVE is a European project. They are working for the security requirement for the vehicle security architecture. EVITA is also a European project. 2.3 is a security is finding the requirement of the automotive on board network based dark side scenario. EVITA 3.1 is the security requirement automotive on board network based on the dark side. These are the upgraded version of 2.3. These are just extending those versions. So 3.2 is providing the security and trust model. How can we develop for the automotive advance of the modern vehicle? Then SAE J3061 is the recommendation for the security and privacy in the era of the next generation car. eScript, Intel, Microsoft, Tesla, Toyota, MIT, and any more organizations those are working for the automotive cyber security. Now we discuss about some examples of the projects like V2X communication security. There is standard related work for the IEEE 609.2 is define the secure message format processing for the web. SAE J2745, they are provided the message dictionary for web communication. NHTSA.HS81204014 is provide the readiness of the B2B technologies for application. And European ETSI, they have defined the so many things for the V2X applications, RH applications requirement and specification, intersection collision risk warning, longitude collision risk warning, the specification of cooperative awareness, basic services, specification of decentralized environmental and notification of the basic services. These are the some basic automated V2X communication securities standard, and organizations who are working there, they're trying to develop their standard. So V2X communication project we discuss here as .HS812014. They are using the SCMS, propose their SCMS system. There is a secure credential management system where there is defined the each vehicle, each SCMS manager will provide that unique information interface ID to the vehicles. There they detect with the help of those misbehavior detection and revocation. Then it change the device interface and provide the certificate processing. And again, this process is gonna be work as a pseudonym and certificate based. So they're providing that hash algorithm, digital signature and encryptions, and it will be provide the integrity protection, authentication, integrity protection, non-repudiation, confidentiality. It's providing these functions for the security of the automotive cyber security. They are providing this type of algorithm for that. Another projects like Reserve, they provide the security requirements, architecture. We already discussed those things. It's just repeated slide. Now this VTX, this project, SCMS project is working like this. Vehicle has a sensors and all things. They connected with the device configuration manager and location observer proxies. Then device configuration management is provided enrollment and certificate and certification lab. Then certification enrollment certification will be used the intermediate certificate authority. And this here dotted one is gonna be explain the is gonna be initial deployment. When we started our communications within a network, then these are the dotted one is provide the initial requirement, and this one is deployment is provide that full deployment. And where is the pink, this line will be provide the out of band communication, and this dark black one line is provide the regular communication is happening. So this is the some structure of the whole V2X security, how gonna be connected with the whole system, how gonna be communicate in the system things. And then is the additional needs for this comparison between the NHSTS and ETS is requirement. Concept vehicular communication gateway. There is automated cyber security. They're providing a MAC, message authentication code, prevention data transmission, anomaly detections. The key point is key code in each data and each ECU has matching the key enough key to decode. Each ECU check all CAN message ID, disable the messages if ID is assigned to myself, and central gateways provide the monitor CAN bus and detect the anomaly messages. What is the pros and cons of this? The strong security. MAC, message authentication, has a strong security. CAN bus load increase. Key algorithm management. Each issue has a software changes. That is the drawback. And low security, each issue software change. The protection, prevention of data transmission. Additional central gateway, no change existing the system. For this they are using the security algorithm. For the MAC, they are using the key management algorithm, and anomaly detections, they are using the anomaly detection algorithm, where are using the machine learning applications. So that is the V2X cybersecurity. Now in this slide we are going to discuss about the in-vehicle security. In-vehicle security has like these are the some points of the inside of the vehicles needed the security. We use the MCU, MPU, the serve brain. These are the machine control unit. There is use of secure the processing. Then secure the onboard. There is a onboard communication. We use the secure transmission. We need the secure network. Secure car access. We need to secure key lock implementation, NFC, etc. Secure gateway. We need to secure routing and firewall things, and from back side we need the secure interface where we connected the V2X and media our telematics services. For example, the European project EVITA is providing the key protection, trusted computing based, secured storage and case affecting thing project. This in this project, and there is another Japanese agency's IPS guide, which vehicle system model of the IPS is to provide the basic consider of the process. So these are the two example of the two projects, EVITA and GPA projects. There we are focusing on the in-vehicle security, in-vehicle cyber security. Now autonomous vehicle cyber security updates. Cyber security guide for the CPS vehicle system is published 2016. They provide a framework to help organizations identify the access cybersecurity threat related vehicles, design the cybersecurity into cyber physical system throughout the entire development life cycle process. They provide the foundation of the further standard development. OTA update the over the air and software updates are the crucial part of strategy. Already implemented by the vendors such as the Tesla Motors, needs to be the carefully implemented as OTA service can be hacked. These are the some basic informations. Second, share the expertise. Automotive Information Sharing Advisory Center. We use the Auto ISHAC for the establish the auto industry to facilitate development cyber security expertise within the automotive supply chain. An industry operated environment created the enhanced cyber security awareness and coordination across the global infrastructure of automotive industries. So this is the conclusion. Now I'm going to conclude that my talk. So there is the conclusion. Industry has started to address issues of the cybersecurity of vehicles. Cybersecurity issues of the connected cars remain poorly understood. Fragmented business ecosystem and global supply chains make compliance difficult. Legal and regulatory framework lags well behind trade and technology development. Risk that high cost may result in the cybersecurity being given the lower priority than is required. Need to think about cybersecurity from the standpoint of vehicle life cycle, from the initial sale, resale, and end of the life. So we need to think about this all cybersecurity issues for our vehicle systems, our automatic technology.